Plastics is the term used to describe a wide range of synthetic and semi-synthetic materials which are used for a variety of functions. The discovery of plastics during the 20th century has been invaluable for manufacturers across several diverse fields. Today, plastics are used in packaging, building and construction, transportation, electronics, agriculture, healthcare, sports, and within the energy industries. Plastics originate from a complex manufacturing process which utilizes crude oil to create multiple unique mixtures through the use of hydrocarbon chains which differ between size and structure. A large proportion of plastics produced today are still used for short-term purposes such as shopping bags and packaging materials, and less than 1% of all plastics which are discarded are ever recycled. Compared to other manufactured materials, plastics take a great deal of time to decompose. Depending on the type of plastic, decomposition can take from 10 to 1,000 years. Plastic shopping bags take the most amount of time to decompose. Products such as these are responsible for a large proportion of pollution within landfills, sewage systems, and oceans. Plastics break down into smaller fragments. These are often referred to as microplastics and enter oceans through bodies of water, through effluent discharge, aerial dispersion, or directly from polluting activities. Photo and biodegradation of plastics on land produces environmentally unfavorable consequences, as the breakdown and release of chemicals during this process may result in wildlife being harmed should they ingest decomposing plastics, and soils may be contaminated through leaching. Similarly, when plastics enter global seas, they are continually ingested by biota, resulting in a number of severe consequences for said organism. Research has shown over 690 different marine species have ingested plastics in the form of microplastics, and fragments have been found within their digestive tracts. Direct ingestion of microplastics leads to limited food uptake due to blockages of feeding appendages and the alimentary canal. Furthermore, microplastics can be absorbed by epithelial cells and translocate into the circulatory system. In addition to the physical harm microplastics particles impose on aquatic organisms, subsequently, they can be contaminated with a number of different pollutants. These pollutants include fluorinated and sulfonated organic compounds, pharmaceuticals, estrogen, pesticides, heavy metals, and pathogens. Ultimately, marine biota's ingestion of microplastics leads to human consumption of microplastics. Researchers have found that consumers of shellfish ingest approximately 11,000 microplastic particles annually. Furthermore, researchers from the University of Newcastle have estimated that humans consume over 250 grams of plastic annually. For plastics which have already been consumed by biota, it is difficult to provide relief for these organisms. However, steps can be taken to reduce the amount of microplastics consumed by organisms in the future. Therefore, we propose two solutions to reduce the amount of plastics used for packaging, and to recycle plastics which have already been manufactured. Previously, others have tried to provide substitute materials for plastics for different products. One such example is the use of seaweed as the material used to construct grocery bags. Seaweed, unlike plastics, are biodegradable and naturally found in oceans and consumed by organisms. An alternative material is cassava, which is a root vegetable native to South America, which has also been developed and used as a material for the production of grocery bags. Cassava, like seaweed, is biodegradable. The bags which have been developed dissolve in water. Additionally, they pose an insignificant threat to organisms which consume the bags, including humans. Building upon these contributions, we can re-examine the use of plastics as a packaging material. If these organic materials are able to be constructed into plastic bags, they could also be constructed and used as plastic wrapping for packages, thus reducing the use of single-use plastics within a variety of industries. Our second suggestion for easing the ever-growing plastic pollution problem is recycling plastics into previously overlooked products. Plastics can be recycled and repurposed into new products such as bottles, bags, pots, bins, drainage systems, and a few more besides. And whilst recycling plastics into these materials is beneficial, more products could be created out of plastics. One such example is toys. The global toy industry is quite extensive and consumes a great deal of plastics to create their products. Additionally, most of the products which toy manufacturers create are produced for single usage, and recycling of said products is not taken into consideration. If toy manufacturers were to adopt the use of recycled plastics into their manufacturing process, this would repurpose a great deal of discarded plastics globally. Our aim, through implementing these two solutions, is to minimize the use of plastics for materials such as packaging and wrapping, and to recycle existing plastics and produce products such as toys using these materials. Ultimately, recycling plastics leads to less pollution within oceans. Additionally, the use of alternative biodegradable materials would not harm marine life should these products enter oceans. Some may even dissolve upon coming into contact with water. Therefore, the two key issues which relate to plastics polluting the world's oceans are addressed within our proposed solutions. Firstly, we are reducing the amount of single-use plastics, therefore we are reducing the amount of microplastics entering oceans. And subsequently, whilst we cannot completely eliminate direct pollution from our oceans, we can swap out harmful materials such as plastics for safer, more environmentally friendly materials.